All right, so let's actually talk about the data model. What is it? What is the data that we're trying to retrieve? We already hinted at that, right? We want to represent courses, something that perhaps the hand-in server needs to keep track of, right? A list of courses. Courses have a whole bunch of assignments, have folks that are enrolled in those courses. So there's lots of, there's a lot to model there. We're just going to keep it really trivial. We're just going to model a course, right? And so a course is just going to have two attributes, just a unique identifier and the title of the course. You could have all sorts of other things here, right? Who the author is, when the course is starting, maybe any sections that are associated with this course. But again, we're going to keep it really, really simple with course. So let's create that here. I'm going to create a couple of packages here. My first package, I'm going to put all my models under a models package. And I'll put in there my first model. So it'll be course.java. And in here it'll have just private integer, private integer ID and private string title. Okay? And we can then generate the setters and getters that go along with this. Now here, normally, you would only implement the setters and getters if you absolutely needed them, right? But here we do need them since this class is eventually going to be mapped to a database row, right? Instances of this class are going to be inserted into a database, and I'm going to have to be able to read rows in a database and map them to instances of this class, yes? And for that magic to happen, I need to follow some minimum standard, right? And one of the minimum standards is that I need to be a Java bean, right? The Java bean standard is that I need to have setters and getters, right? Publicly available, and I have to have the no argument constructor. So I have to have the default constructor, which I do, right? So notice that I'm not overriding the constructor, so I already get the default constructor. Make sense, right? And the magic will happen as it will instantiate, when it tries to map records to instances or instances to records, it will instantiate these objects, right? And it'll populate them using the setters, right? So when it's reading from the database, and when it's going into the database, it will grab an instance of this object and will use the getters to read the values and then insert them into the database. Make sense? Right? As long as we maintain this minimum requirement, then we are good. We are a Java bean. The other idiosyncrasy here is that I have this unique identifier, which in Java is kind of an overkill, since it's object orientation, right? We are instantiating these objects. These objects are already unique, right? They have a unique memory space where they are stored. And usually the pointer to this memory space is enough for uniqueness, right? The instance is unique. There's no point in making a unique identifier. The reason we're putting an identifier here is that I know we're going to be stored in a database, and the database demands a column that is a primary key, a unique identifier. Yes. So I need to play by that rule that this field will map to some column in the database, which is the primary key. Make sense? Right. Otherwise, I would not have this primary key. Yes. I'm sorry?
Is there a reason why you use the object integer?
Oh, no, I could use a plain all integer. That's fine. Yeah, primitive data types are just fine. Yeah. This is just a little bit more convenient because I can compare it against null. All right, so that's one. So this class is going to map to my tables. The next data model that I'm going to use is mostly for mapping it to my XML files, right? So my XML files, by definition, XML files demand that there is a root element, and then inside of that element, you can have anything you want in there, right? But you have to have a root element. Again, that's an idiosyncrasy of the data types or the data storage mechanism that we're using. Right? So SQL has its idiosyncrasies, and XML has its own idiosyncrasies. Yes, and oftentimes the worlds don't map very nice. Okay, they don't play nice with each other, and that's where adapters come in. How do you adapt this world over here of a very flat way of storing data with very small data types in a relational database, compare it to a very hierarchical representation in XML, where you can have elements within elements within elements. It's very, very hierarchical. So how do you map these things? And also its schema, its data types are much, much more richer than relational databases, right? So that's where adapters come in. So let's have a courses. So we'll have courses here. And courses is going to have one field, which is going to be a private list of course. Let's import that, and this is courses. And we'll generate the setters and getters. There we go. So this one is not going to be stored in a database, right? So there's no ID. Right? I don't have to play by that. Instead, it's going to be mapped to some XML document, which will have a root XML document element, and then internally it'll have any number of courses. Yes, right. So let me just show you what that might look like. Let's see. Do I have one here? So the XML will look something like this, right? It'll be a root XML root element courses, and then internally you'll have several course instances of elements in there, right? So courses in plural, and then you have course in singular inside, right? And so we're going to try and map these two worlds, right? Based on some of these idiosyncrasies that almost look identical, look like they're somewhat compatible, but not quite. Right? All right, so we have course, we have courses. All right, so we have the actual pieces of information that we're going to be manipulating, and now we're going to also need the actual implementations that are going to be manipulating these two worlds. Right. First, we'll declare an interface. Right. One interface that we'll use to implement our communication with the database, and we'll create another interface that will implement things that for communicating with our XML world. All right. So let's do that. So for communicating with the database, we'll create this interface. We'll call it course DB DAO, right? DAO. Right. Here's another design pattern. Right. The DAO, the data access object design pattern. There's tons of design patterns. If you grab the design pattern book that we suggested early on, you'll find lots and lots of these really cool design patterns. One of them is the DAO design pattern. That design pattern says that if you're communicating with any data source, regardless of what the data source is, where you're getting the data, it's a good idea to encapsulate, right, and modularize all data access into one class, or maybe several classes that work together. Yes, right. So any operations that are communicating with a database or an XML file or whatever, right? They should all live together in one single place. Yes, right. You should not instead spread it out everywhere in your code. It should be all centralized in one place. It's reusable. It provides a nice API so that it hides all the details from everybody else. So internally, the implementation is that I'm either talking to an XML file or I'm talking to some remote database or halfway across the world. Yes. So the API should hide all those details for us. Right? And in this particular case, we have this interface. So it's the course DB DAO, and it's declaring these two functions. There are many other functions, but these two particular functions allow you to retrieve all the courses, right? And whereas the other one allows you to retrieve an individual course. If you know the primary key identifier for the course, I can go fetch you that one record or I can return you a list of courses, right? All of them. Make sense? Right? Obviously, in here you would have many other methods. Maybe create a course, delete a course, right? Update a course. So you would have all the CRUD operators here, right? What we mentioned yesterday, right? That typically those are the 4 or 5 operations that you do on any data type. Create, read, update, delete, and 2 versions of read. Find all, read all, or read one. All right, so we have this interface. Let's declare this. Maybe we'll create a package here, and we'll call it the DAOs. And under the DAOs, probably we'll notice that we'll have 2 interfaces: one that talks to a database and one that talks to XML. Yes, right. So let's create packages for both of them. So maybe we'll create another package for XML and another one. Oh, really? I didn't mean to do that. DAOs and then DB. There we go. So under the DB, we'll create the iCourse DB DAO. So this is new Java class. It's an interface, and it's iCourse DB DAO. And in here, we declare things such as public list course, where we can retrieve all the courses. And this will be something like find all courses. And the other one allows you to retrieve an individual course, such as find course by ID. And you have to specify an integer course ID. All right. And additionally, you would have things here such as public course, create course, and this would insert the course into a database and retrieve and return to me the actual record that was inserted into a database with a brand new primary key. You would have also maybe update course with the course that you want to update, plus probably the integer of the course ID that you're trying to modify, and then the new data for that course. And probably also you'll have something like void delete course would be here as well, integer course ID. Okay? We're just going to focus on the first 2, find all and find course by ID. All right, and maybe you can play around implementing the other 3. Okay? All right, so we have that. Let's implement now the XML version of this, the interface. Again, this is an interface, and it'll be interface course XML DAO. And this will be working with an XML document, right? And instead of returning a list of courses, it would return a courses object, right, that contains a list of courses. Yes, right. And we can already see how we could build one in terms of the other, right? We can already start looking ahead. So here we have public courses, and this might be read courses XML document, right? Or maybe you want to retrieve a particular course, read course XML element for ID, and we would provide maybe an integer for the course ID. All right. Plus, you would also have maybe things that will allow you to update the XML document, remove things from the XML document, modify an individual XML element, and whatnot, right? But I'll leave that to you, etc. All right, so how do we implement this? We want to create implementations of all these, right? So let's take a look at implementing all these. All right, how do we bind all this to the database?